medical team can't give him tablets by mouth because he's disoriented. Giving him anything by mouth could cause him to choke. So he's given a small injection of 3% sodium chloride. Small injection because he doesn't need any more fluid, and 3% sodium chloride being saltier than isotonic 0.9% saline. Within a few hours, JW produces gallons of urine. His kidneys are able to exchange the salts for water as it starts pouring out of his body. His seizures stop and he regains consciousness while medicines are given for his alcohol withdrawal. The medical team repeat 3% sodium chloride injection 2 more times throughout the day to help with the cerebral edema. As the days go by, JW's sodium levels normalize. He's in stable condition. He gets vitamins and proteins. He recovers and is well enough for discharge from the hospital. But just before doctors sign off on the discharge, JW complains of general weakness. His speech is slurred and incoherent. Neurology consult finds coordination deficits in JW. His movements in the limbs above his waist were uncoordinated, with intended positioning often missing the target at varying lengths. This is called dysmetria. Dys meaning wrong and metria meaning length. Similarly, he had dysdiadochokinesia, meaning that his ability to perform rapid alternative movements was compromised. All of this pointing to some possible neurodegeneration in JW that has worsened since his hyponatremia was corrected days ago because he didn't have those problems back then. He's not ready to be discharged. As the hours go by, he becomes weak in all 4 limbs. Nurses ask him to move his arms and his legs, but no response. His muscles are floppy as his limbs become paralyzed, and an MRI of his brain reveals that JW has central pontine myelinolysis. Lysis meaning a breaking down of myelin, the conductive sheath that covers nerve cells, and central pontine referring to the central pons of the brain where it connects to the brainstem to deliver nerve impulses all throughout his body. If his hyponatremia has been corrected and JW has been sober for many days now under medical supervision, then how could he just suddenly become paralyzed? Well, do you remember the name chronic hyponatremia? Well, chronic means that his body has had low sodium presence in blood on a time scale of at least weeks to months because of that 50 beers only that he drank every day. When sodium presence in blood starts to decrease, water starts to float into the cells pretty quickly. The brain does start to swell a bit in this initial phase, but the brain has an outlet called the cerebrospinal fluid, which flows into the spinal cord and cushions the brain inside of the skull. When hyponatremia is chronic, the swelling, even if it's slow, keeps happening, and the brain is forced to pump out organic salts, or carbon-containing salts, to further prevent the swelling. These organic salts are like sodium in that wherever they are, water will flow towards them too. So when they're out of the brain, water will follow them out. And because of this adaptation, this is why JW's brain doesn't immediately swell up after just a couple of weeks of drinking 50 beers every day, because as he was slowly losing sodium day by day, the adaptations in the brain were adjusting to the chronic hyponatremia. Sodium correction in a patient like JW is difficult because of all the metabolic derangements inside of his body, some of which are unmasked after initiation of therapy. His adaptive brain started to shrink in the presence of sodium. Sodium and potassium rushed into his brain cells by design without the proper presence of those organic salts, because those take time to get pumped back in to the brain cells. When there's a high sodium presence inside any cell, the DNA there starts to break. The cell thinks it's been mortally damaged and initiates programs